Hello everyone. In this section we will be covering measures of position, and the main measure we're going to focus here is on percentiles. So the question, what is a percentile? Well, most of you have taken a standardized test at some point in your life, like maybe you took the SAT or ACT test in high school. Now when you take these exams, your score is usually given in a percentile. So you don't get an A, a B, or a C. Usually the score will be like the 80 percentile. So what does that mean? If you score in the 80 percentile, well, first of all, it doesn't mean that you got 80%. All it means is that you score better than 80% of the people that took the test, which also means that you did worse than 20% of the people that took the test. So this is going to be important for later. So how do you find percentiles? Well, here are the steps, and this is actually fairly easy. Remember that n is the sample size or the data size. K is going to be whatever percentiles you want. So if you want the 17 percentile, then K will be 17, and 100 is because we have percentages. Now step one is the key to make this very easy. So notice that here you have to divide, you multiply and then divide. But whenever you divide two numbers, there is only two things that can happen. You either get a whole number or you get a decimal. So let me show you three different pre-examples before we do an actual example. So just remember that when you divide two numbers, the key is that you either get a decimal or you get a whole number. And depending on what you get, you're going to do a slightly different thing. In step two, the L stands for location or position. And by location or position, I mean this. This is the data set we have. So I highly recommend you to do this before you start the problem. So this is the first location, this is the second one, the third one, 4, 5th, and so forth. 8, 9, 10, 11, 12, 13, and 14. So which means that n is 14. So before we do an actual example, let's do three, which I will just call pre-examples. Let's say that for step one, and I'll show you how to do step one right now, you end up with 7.1. Now, if you were rounding, 7.1 rounds to 7. So here, we're going to round in a different way. You always want to round up. So 7.1 is going to round up to 8. So this will be the 8th position. Now, which one is the 8th position? The 21. So therefore, the percentile that you're looking for, it will be the number 21. Okay, let's try this like 3 times before we do an actual example. Let's say that for step 1 you get 9.8, which clearly is a decimal. So you get a decimal, every time you get a decimal you go to the next whole number. In this case, this will be 10. Make sure you write the 10, because that means the answer is on the 10th position. Well, which one is on the 10th position is number 23. So you can see this is fairly easy. Now the only one you have to be careful is when you get a whole number. Let's say you get the number 12, which clearly this is a whole number. So what do you do then? You get a whole number, you add 0.5 to it. So add 0.5 to the position. So now you have to look for the 12.5 position. How do we find the 12.5 position? Well, you add position 12 plus position 13 and divide by 2. So in our case, position 12 is 28, position 13 is 39, then divided by 2, which will give us 35.5, and this will be the answer. So remember, if you get a decimal, you round to the next whole number, and you get a whole number, you add 0.5 to it. Okay, so let's do a example now. The question is asking us to find P35. So this means the value for K is 35. So step 1, which is the only one we haven't done, you need to do NK over 100. So in our case, remember N is 14 from here. That's the total number of points. K is 35 divided by 100. So you multiply everything and divide, you end up with 4.9, which is a decimal. So remember, you get a decimal, then to find the location of P35, you round this to the next whole number, which in our case, this will be the 5th location. Well, the answer is going to be the location number 5. So which one is location number 5? Location number 5 is the number 18. So the answer is 18. So it is that easy. That's all you have to do. Very, very, very simple. Well, you didn't get that one. There is 3 more chances to redeem your sin. So let's try that again. So for this one, the value for K is 25. So let's go to the steps again. For step 1, now we're going to do 14, which is the value for N, times 25 divided by 100. And this is equals to 3.5, which again is a decimal. Remember that you get a decimal, you round it to the next whole number. So therefore, the location or position of P25 is going to be the 4th position. Well, which one is the 4th position? Position number 4 is the number 17. So that means P25 is 17. Okay, very, very simple. Let's do now one where you get a whole number at the beginning. So what about P50? So for this one, K is 50. So let's go to the steps. So step 1. Remember that you can use the formula sheet on the exam. So all these steps will be there. Okay, so for step 1, you have 14 times 50 divided by 100, which is equals to 7. 7 is a whole number. So remember, you get a whole number, you have to add 0.5. So therefore, the location of P50 is going to be the 7.5 location, which means you need to add location 7. What is location 7? It's 20 plus location 8 and divided by 2. Remember, this is the 8th location, this is the 7th location, and you divide by 2, this is equals to 20.5. So this is the 50 percentile. Notice that means 50% is more and 50% is less. And we did that before. This is actually the median. So the median is nothing more than actually a percentile. Okay? Now finally, and you should check this on your own, this one is going to be 2024. How? Well, remember, for step 1, we're gonna need 14 times 75 divided by 100, which is 10.5, which is a decimal. So therefore, for step 2, the location of P75 is gonna be the 11th location. Well, which one is location number 11? Is the number 24. Okay, from here. Okay. Now I will show you before this section is over how to find this in the calculator. The calculator can actually find 25, 50, and 75. It will not be able to find something like this one, but if you have a TI-83 or 84, you should definitely use it because it will save you some time. However, you can always use the steps and find any percentile using the formula. Well, the calculator will only give you 25, 50, and 75. And we will talk more about that in the next slide. The next thing we're going to cover is called the fine number summary. And all of this is related to exactly what we did right now to the previous page. But you change the numbers a little bit, but it's going to be the same thing. Remember that this was the data set we were using. So I'm just writing it again here so you don't have to look back to the numbers. So now the fine number summary is related 100% to what we just did. We just, like I told you, just change the names. So now we have something that is called Q1. So Q1 is going to be the first quartile, but Q1 is nothing more than P25. So P25 is the first quartile, which makes sense because 25 cents is a quarter. Then Q2 is going to be the second quartile, which again makes sense because 2 quarters is equals to 50 cents. And finally, Q3 is going to be the third quartile, or 3 quarters is 75 cents. So therefore, this is technically P0, P25. Remember, this is the minimum. This is a P50. This is P75. And this one you can call it P100, like the Tesla P100. But this is also the maximum. The only ones you actually had to find are these three, because this is already given. This is the smallest, and this is the maximum. So you don't have to find this. So this is the minimum, this is the maximum, so they are given. So we have done all the work already. So therefore the lowest is 7, or the minimum. Q1, remember, was P25, but P25 from the previous page was equals to 17. Q2 was equals to P50, which was 20.5. And Q3 was P75, which was 24. And finally, the highest, or the maximum, which you can also call it P100, U1, this is equals to 48. That's a fine number summary. Now, how do you find this using the calculator? Assuming you have a TI 83 or 84 or 83 plus or whatever, but it has to be TI 83 or higher. So this is what you have to do. The first thing is you go to Stat, just hit the key Stat, and then go to Edit. When you go to Edit, it's gonna give you a choice to input the data. So actually, anytime you need to put data in, you have to do a Stat Edit. So then it's gonna give you a choice of lists like this: L1, L2, L3. So enter the data on the first list. So like the first value is 7, then do enter. Enter, make sure you put all of them in the same list. Then 9, enter, and so forth until you get to 48. Be very careful when you add the data, because if you input one number wrong, everything will be wrong. So first you do this. Second, you put all the values in. Third, go to Stat again, but now you're gonna hit the next key, which is Calculate. And then when you go to Start Calculate, it gives you the choices 1, 2, and so forth. Make sure you pick number 1, which says 1 variable stats. So once you click on that one, on the screen, it will look like this. Then go to a second and make sure you pick L1 where you put the data. Once you do that, it will give you a lot of information. It will tell you X bar. It will tell you the standard deviation. It will tell you the sum of X, the sum of X squared, and then you keep scrolling, it will tell you the minimum, which should be 7, Q1, which should be 17, Q2, which is also called the median, which will be 20.5, and so forth. So you don't want to do this by hand. You can just use a calculator. So I highly recommend you to use it. Just keep in mind that the calculator will not find a percentile like P33 or P66 or something like that. It only finds 25, 50, 75, and so forth. Okay. Now, the last thing to do in this section is, well, how do you display, the last thing to do in this page, how do you display this data? There is something called a box plot, and you can draw the box horizontally or vertically. So the first thing you should do is do a line like this, and then literally just do a box, and then extend it this way. So this will be the lowest, this corner will be Q1, this other corner is Q3, and this is the highest one. Then on the middle, you do 2 lines, and that's going to be Q2. In our case, this was 7, this was 17, 20.5, 24, and then 40, 48. Again, you can also do this vertically if you wish, but this is the most commonly used way to represent the final number summary. So the reason why you need 2 bars here is that if this is too far to the left, then you say that the data is skewed to the right, and if it was farther to the right, then the data is skewed to the left. All right, so let's go to the last page. The last thing that we'll be covering in this section is the topic of outlier or outliers, and we mentioned this back in chapter 3. So an outlier is a data point that is too big or too small compared to the rest. So here is the key, compared to the rest. So this can be tricky by just looking at numbers. For example, if you look at this, it looks like 48 is too big compared to the rest, and 7 kind of small, but you cannot use that as a predetermination to say this is too big and this is too small. You have to have an official way to get to that. So this is how we're going to do it. The first thing you find is the interquartile, which is Q3 minus Q1. Remember that Q3 is nothing more than P75, which we already found, and Q1 is P25, which we already found. Actually, let me write that out again here. Remember, Q1 was 17, and Q3 was 24. So therefore, the interquartile will be 24 minus 17, which is equals to 7. Then we find a lower bound, which is Q1, which we already have, 17, minus 1.5 times the IQR, which is what we just found right now, well, the IQR happens to be 7. Be careful to follow the order operation, so you need to multiply this first and then subtract this value. It is okay if this value is negative, but make sure you do this first and subtract it from this one. So in this case, this is equals to 6.5. Then find the upper bound, which this will be 24 plus 1.5 times 7, and again, be careful with the order operations. Once you do that, you should get 34.5. All right, well, so how do we determine if we have outliers or not? So this is what you do. Once you find the lower and the upper bound, the lower bound is 6.5 and the upper bound is 34.5. So anything in here, between here and here is okay or normal, whatever that means. So this is related to the fish problem we did earlier too. So if it is between 6.5 and 3.5 is okay, and 34.5 is okay. If it is here, is an outlier because it will be too small, and if it is here, it will also be an outlier because it will be too big. So the last thing you have to do is look to the list, the original list we start with. Do you have any numbers less than 6.5? No. Do you have any number bigger than 34.5? Yes, these two. So therefore, 39 and 48 will be outliers. Remember that outliers are supposed to be rare, so these are supposed to be rare. If there is too many of them, that means you did something wrong. As a general rule, if you find more than 3 on a regular data set that is this small, you should check your calculations again. And it is perfectly normal to not have any outliers. For example, let's say that this value, instead of 34.5, it was 50, then there will be no outliers. In our case, these are the two outliers, 39 and 48. As you can see, this is very, very, very simple. And also notice that everything goes back to finding P25, P75, and P50. The whole section relies on that. All right, so that's the end of 3.3.